I'm going to talk about laws of exponents in this video. And laws of exponents can be tricky the first few times you see them, but we'll work through them and try to break them down into different parts that'll make them a little bit easier. The three laws of exponents I want to talk about today are the three that I have highlighted, which I'll kind of break down here in a second. What the first law that I have highlighted here says is that if I take two like bases, so the base would be the number that's being raised to some sort of power. In this case, x would be the base. And I'm multiplying two like bases together. What I can do is I can add the exponents to write this as a single expression. So this would be x to the 3 plus 2, which is equal to x to the 5th. Okay? The reason that is if you think about what x cubed is the same as saying x times x times x, so I could rewrite it this way, and x squared is the same as saying x times x. And if I were to multiply all these x's out, you would notice that I would have x to the 5th, or 5 different x's. Okay, so that's the first law of exponents that we'll talk about today. The second one is very similar. It's just going to deal with dividing like bases. So if I had, let's say, x to the 4th over, let's say x, that would be like x to the 1. That would be x to the 4 minus 1. So the shortcut is I can subtract the exponents, which would be x, in this case, x to the 3rd. Now again, the reason why this works is if I were to rewrite this as x to the 4th being, 4 x's up here multiplied together, and then this x to the 1 on the bottom just being a single x, remember that we can cancel anything on the top with anything on the bottom here, so this would cancel, that would cancel, and I'd be left with x to the 3rd, x times x times x. So again, the shortcut on this type of problem would be that you can subtract the exponents if you're dividing like bases. So we can sometimes add them if we're multiplying like bases, we can subtract them if we're dividing like bases. Now finally, the last one I want to talk about here today is negative exponents. These are tricky because people think this is going to change the sign of their number. All a negative exponent does, like let's say I have x to the negative 2, is it moves it to the opposite side of a fraction. So if I have x to the negative 2, it's just 1 over x squared. Another example, and you can punch these in your calculator too if it's a number to check it. If I have 3 to the negative 2, it's like squaring 3 and moving it to the bottom of our fraction. So this would be 1 over 3 squared, which is just equal to 1/9, or 1 over 9. Okay? Another possibility, we'll go with one more. Let's say we had 5 over x to the negative 2. So if I had something like this, if our negative exponent is on the bottom, we need to move it to the top and make it positive. So when I move this up, it'll be 5. We're going to move it up with the 5, x squared. Okay, so negative exponents are kind of like an unsimplified fraction. Like I would never write an answer of 2 over 4 on a test. I would always try to reduce that to 1/2. Negative exponents are the same way. If you get an answer, that has a negative exponent in it, you want to take the negative exponent and move it to the opposite side of a fraction from where it was before. Okay? So if you ever get an answer with a negative exponent, we're going to get rid of those and move those and make them positive. All right, let's try some examples here of each of these different laws of exponents. So again, we talked about this first one already. When I'm multiplying like bases, we said that we can add the exponents. Again, the reasoning be, if I have 3 times 3, or 3 times itself 5 times, so there's 5 here and there's 2 here. That's a total of 7 3s. Now, we'll go ahead and kind of look at this. So if we add the exponents here, this would give us 4 to the 9th. On a test, we could actually write what that number would be, but for today, we'll just leave it as 4 to the 9th. The next one, on these types of problems, if I don't see an exponent on the x, remember that there's an invisible 1 hiding there. That's x to the 1. So x to the 3rd times x to the 1 is just x to the 4th. Next one, this is tricky. So a common mistake is people want to add these numbers out front. They want to say 5m to the 5th. But remember, you know how to multiply these. This is multiplication, and you know how to multiply big numbers. These two big numbers are going to equal 6. 2 times 3 is 6. It's only the little numbers that we're going to have to add here, m to the 5th. So we only add the exponents, not the coefficients in front of them. Okay, so it'd be 6. 2 times 3 is 6. M squared times m to the 3rd is m to the 5th. Okay, next one. We got 3 times 5 is 15. X squared times x to the 4th. We add the exponents, so we get x to the 6th. And last one here, we got a little bit of a mix. Negative 2 times negative 7 is negative 14. And if we combine the x's, that's x to the 5th. And if we combine the y's, we add them, we get y to the 4th. And that would be a little introduction to the first law of exponents that we talked about here. Okay. Next one. Okay, we said that when we are dividing like bases, we can subtract the exponents. All right, so if we look at this one, again, I'm going to write this first example over here just so you guys can see what's going on. If I had 5 3's multiplied out with 2 3's, I could cancel 2 of those, and we'd be left with 3 to the 3rd or 27. We'll leave it as 3 to the 3rd for today. Again, the reason that would be is, or what the shortcut we can do instead of writing all this mess out, is just subtract the exponents. 5 minus 2 gives us 3. So we'll do just that over here. So 10 to the 5th over 10 squared is going to be 10 to the 3rd. Okay, we subtract the exponents. X to the 9th over x to the 4th is x to the 5th. We will subtract the exponents. 8 over 2. Now here again you have to be careful. It's not going to be 6. We're not subtracting big numbers. We know how to divide 8 divided by 2, or just simplify that fraction. It's just going to be 4. Okay, 8 divided by 2 is 4. It's the little numbers here we need to subtract. So these exponents, x to the 7th over x to the 1 is x to the 6th. All right, still moving along. Again, 9 divided by 3 is 3. X to the 7th divided by x to the 5th is x squared. There will be 2 x's left on the top. And y to the 7th divided by y to the 3rd. Again, if we cancel 3 of those y's, there's going to be 4 left on the top. That would be our answer for this one here. Okay, we're going to get into negative exponents here really, really quick, and then we'll try to wrap this video up. So we've got 2 to the negative 5th. We said that's the same as saying 1 over 2 to the 5th. Again, I could leave it that way. For now, I'll actually write this as 1 over 32. So I will actually evaluate some of these. Okay, 10 to the 5th. Again, it's not negative. It's not going to be a negative number. It's going to be 1 over 10 to the positive 5. So whenever we move it to the bottom or move it to the opposite side, it becomes positive. And then from this point, we're just going to evaluate that. We should have 5 zeros. That would be 100,000 there. Next one. Anything to the negative 1 just takes the reciprocal of that number that's being raised to the negative 1. So in this case, 4 to the negative 1, we just move 4 to the bottom. 4 to the 1 is 4. Again, if you want to pause here and try these next two on your own, you can, but this one should be 1 over 6 squared, which is 1 over 36. And finally, we would have 1 over r to the 10th for our last answer here. Okay, so that takes us through negative exponents, kind of a little introduction. We'll get a little bit more crazy here. Again, same thing here. It's a negative exponent. We'll move it to the bottom. That's going to be 1 over p to the 6th. For 16 here, there's a few ways you can do this. You can either move the a to the bottom right away, or let's start by just adding the exponents. We're multiplying like bases. So this would be a squared. So 4 plus negative 2 is 2. So we're left with a squared. On 17, there's not really anything to combine. I can't combine a t with an s. So all I'm going to do is get rid of this negative exponent by moving it to the bottom. The t will not move, so the t is going to stay put because t has a positive exponent. However, that s to the negative 2 is going to move to the bottom and become positive. Okay, number 18. Again, there's a few ways to think about this one. We could subtract the exponents, but be careful, because if you subtract the exponents here, you're going to have 2 minus a negative 4, which will become m to the 6th. Another way you could think about this one is if you had m to the negative fourth on the bottom, you could move the m to the negative 4 to the top and make it m to the positive 4, and then we could add the exponent. So there's a whole bunch of different ways to do these problems. You have to just find the one that makes the most sense to you. Finally, number 19, we could subtract here. We would get x to the negative 1, so 2 minus 3 gives us negative 1, but we don't want to leave that in our answer, so we're going to write 1 over x to the 1, or 1 over x. That's actually not my preferred way of doing these problems. You can do it this way, but personally I think the easiest way is think about canceling. If you had 2 x's on the top and 3 x's on the bottom, we don't even have to mess with negative exponents. These would cancel, and you have 1x left on the bottom. So it's just 1 over x for our final answer there. All right, we're almost done here. So if a negative exponent's on the bottom, we said, it's got to move to the opposite side. So we can't leave negative exponents on our answer. We're going to move this r to the negative 3 to the top and make it positive. So it's just r to the third. Next one here. Again, I could subtract the exponents. Me personally, though, so I'm going to leave the a put here. I'm going to think about this like canceling. There's 3 n's on the top and there's 5 n's on the bottom. Since there's more on the bottom, the n's should move to the bottom after I cancel, and you got to think about how many are left. If you cancel these 3 with these 5, there's going to be 2 left on the bottom. All right, next one. So we've got 12 over 4. This should simplify to a 3 on the top. And then, again, you can either subtract your exponents. I'm going to think about this one like moving these up. If I move these 4 b's up to the top and make them positive, so if I switch the side of the fraction it's on, it's going to make it positive. And then at this point, I could multiply these 2 exponents and add them. That would give me 9 b's on the top. So it would be 3b to the 9th. 2 more to go. So negative 15 divided by 5 gives us negative 3. R to the 5th over R to the 5th, well, actually all the r's here are going to cancel, so there won't even be any r's left. We'll talk a little bit more about that in our next video when we talk about 0 powers, but those should just cancel out. And then again, if we look at our s's, there's more s's on the top, so the s's should be left on the top, and when these 2 cancel, there's going to be 6 of them left on the top, so that should be negative 3 s to the 6th. Okay, last one here. We've got 12 over 60. We'll start by simplifying that fraction. 12 over 60 simplifies to 1 over 5, so 1/5. I wouldn't try to make that a point, whatever here, a 0.2. That's not going to really be the best way to write this. Let's write it as a fraction, so 1 over 5. Next, we've got a c to the 1 on the bottom. If I cancel one of those c's with these 3, there's 2 left, so that'll give me a c squared on the top. Here I've got more d's on the bottom, so if I cancel these 4 d's, there should be 2 left on the bottom. So that's a d squared on the bottom. And then one more time, there's 3 f's on the bottom, 6 on the top. The bottom ones should cancel, and there will be 3 left on the top. So that'd be f to the 3rd on the top. Now, I would go back probably and get rid of this 1. This 1 isn't really going to help me. I don't need that there, so I'll erase it. And then this would be my final answer. So I know I moved kind of quickly through that. I'm going to get through more laws of exponents in my next video. We'll talk about 0 powers, taking powers to a power, and raising a quantity in parentheses. We'll talk a little bit about that too, where we might have to take more than one thing in a monomial to a power. So stay tuned for the next video, and I'll have that going here in just a second.